Hello friends, this is a problem that relates electric field, potential, charge, everything. Now what they have said is, consider a charge profile shown in the figure, and the charge profile looks like this. That is the x-axis, and here it is the charge profile, y-axis is the charge profile, and the charge seems to be constant along the x plus charge and the minus charge. So if you want to visualize this, this looks like this: plus charge on this side and minus charge on this side, constant numbers. So actually this comes from a simple diode where this is represented as a depletion region. So the charge concentration is same. So what they are asking is, if the charge profile is like this, they are asking what will be the resultant potential distribution, V of x. They are asking what is the resultant potential distribution along the x-axis. If you know the charge, how do you get potential? From Gauss law, we can understand that electric field is integral of charge. When you integrate charge, you get electric field. We know that potential is when you integrate electric field, you get potential. So obviously, now the next step is integration of this curve. This graph you will have to integrate. Once you integrate, after integration, whatever you get is the electric field. So y-axis is electric field. How does an integration work? An integration works like this. That is, for example, if you want to know at this y-axis what will be the value for the integration, until this thing you integrate from minus infinity to at this point, if you say origin. So you will have to find the area under the curve until this point. Area under the curve is, it is negative area, and it is, for example, say this is 1 unit and both are 1 units, the area will be 1 unit. So here you will say 1 unit, or say let us say it is 2, for example, x-axis this is 2 units, this is 2 units, that is this is 2 and this is 2. So it is totally, if you multiply area, is 4 units. For example, if you are interested in the area, that is you are interested in knowing what will be the value somewhere here at the here. That is, for example, if you say at the 1 minus 1 units, what will be the area value? The area value will be till this one you will integrate the area till this one, from minus infinity to all the way till this one. So this area is definitely lesser. So it is minus 1 into 2. So obviously that value will be somewhere here. So if you try to find, the area will be somewhat like this. And if you go all the way here, this area and this area will get cancelled. So here again it is 0. Or this is how the final electric field will be. The other way of seeing this is the step signal. If you have a step signal, if you integrate, what you are going to get is a ramp signal. See, we got a ramp here. We got a ramp. After integrating step, we got a ramp. We know that potential is minus integral E dot dl. Again, you will have to integrate this curve. This time you integrate, you are going to get minus integral E dot dl. So integration of ramp will be parabolic. So you can say something like this it will be. So all the area is in the negative side. So the area, the electric field will be like this. Till this point it will increase. Afterwards it is constant. Afterwards it's constant. So it is potential. Y-axis potential, x-axis this one. So this is the answer. So here, which option matches this one? It is the option D. Option D matches this graph. Okay, I'll explain again. See, what is given is a step signal. From the Gauss law, we know that when you integrate charge, you are going to get, when you integrate charge, respect to dx, we are going to get electric field. When you integrate electric field dl or dx, whatever you call it, you are going to get potential. So we integrated the graph, step graph became ramp, ramp became parabolic, and then we ended up with a graph that looks like this. The only option that matches this is option D. Option A is stopping here. We know that it has to go like this, and so that is not possible. And here also it is a mistake. It's like this. So anyways, only option that matches is option D. See, how do you confirm that it is option D? What is that? Is, it looks like a slight difference. Actually, if you take a diode, PN diode, uh, here the meaning of this is, what is the meaning of this? If you have a zero potential here, here you need to give 0.7 volt greater to turn it on. Normal PN junction diode, silicon PN junction diode. Gallium will need lesser, germanium will need lesser. So for example, if you give already here some minus 3 volts, here, minus 0.3 volts, you just need to give plus 0.4. So you can visualize this graph something like that. Already a little bit minus voltage is there. So you need to give a little bit more positive voltage. So potential difference should be 0.7. So what are the ideas that we understood in this question? In this question, we started with the charge profile given. We ended up with potential. Another problem. Here, two conducting spheres and S1, S2, two conducting spheres. It's connected by a small wire, a thin wire, and two conducting spheres. One has a bigger radius, the other has a smaller radius. If so, and they are asking some charge is placed on this structure. They are asking what will be the potential and electric field, which will be greater, which will be lesser, things like that. Now, first is, one thing that we observe is when they are connected, potentials will be same. That's the first thing. Potentials will be same. If potentials are same, that is V on S2 will be same as V on S1. Why? Because it is connected by the same wire. And the next is, what will happen? What is the equation of a potential? Potential is integral E dot dl, and as we understand, minus integral E dot dl. Here you will have to work. Potential means work done. For example, if you take a sphere, if you say the radius is A, what is the potential on this sphere? Since the charges are on the sphere, for example, if you potential means it is work done in moving a charge from some infinite distance to a point A, some infinite distance to point A. What is the work done in moving a charge from here to infinite distance to point A? So electric field will be on this. What will be the electric field? Electric field is Q by K Q by epsilon R square dr. Here dr, because we are all this thing we consider spherical coordinate systems. So dot dl will have r, theta and phi, azimuthal angle, this all these things. So electric field will have r cap, dot product, you will end up getting dr. So if you integrate this, that is minus infinity to point A, you integrate, you end up getting something like Q by K Q by epsilon A. This is the potential you will get for this one. If you call this as S1, if you call this as S1 sphere 1, Vs1 will be like this. If you want to turn K is 1 by 4 pi epsilon. So KQ by 4 pi epsilon naught epsilon R A. This is Vs1. Next is Vs2 will be Q by, if you say here it is Q1, that is because the charges will not be same. Since the radiuses are different, charges will also be different. Q2 by 4 pi, let's just write generally epsilon B. So since these two are same, Vs1 equal to Vs2, it will be Q1 by A equal to Q2 by B. We know that A is lesser than B, so obviously Q1 will be lesser than Q2. This is the first observation we have got, and the next will be what will happen to the electric fields. Electric field is, we have already said, ES1 will be Q1 divided by 4 pi epsilon A1 A square and ES2 will be, so let us say we are interested in the magnitude, not the directions, 4 pi epsilon B square. What will be the relation between E electric field in the sphere 1 and sphere 2, which will be greater, which will be lesser? We know that Q1 by A and Q2 by B is same. If you say this is a constant capital A, so this will be A by 4 pi epsilon A, this will be A by 4 pi epsilon B, or if you say the whole thing looks like V by Vs1 by A, Vs2 by B. It looks like Vs1 is same as Vs2, so Es1 will be greater than the Es2, because say let us say Vs1 and Vs2 are same 100. A is say 1 and B is 2, so obviously 100 by 1 will be greater than 100 by 2. So the option here is, so the answer here is option C, that is potentials are same and the electric field on the A will be greater than electric field on the B.